Because it is on the left side of the mean, the values of x should be negative, isn't it? But here it is saying no, it's positive. To make our calculation easier, let's consider the traditional form. Let's consider this as negative. Clear? That's why I considered minus a. Clear, Mahira? Sure, Baba? Done. Okay. So we are done with our inverse normal distribution. Now we're going to do some word problems. You will see the normal distribution curve or the normal distribution sums are very easy. We have mastered our probability, how to find the probability and how to do the inverse normal distribution. So the standard normal distribution, we know that in the standard normal distribution, the mean is 0 and the standard deviation is 1. But in our real life problems, all the time the mean is not 0. Because in our continuous random variable, the mean is not always 0 and the standard deviation is not 1 always. So if the mean is not 0 and the standard deviation is not 1, then I have to convert the normal distribution to a standard normal distribution. How to convert? So if x, a random variable, follows normal distribution and the mean is mu and the standard deviation is sigma, it is not 0, the mean is not 0 and the sigma is not 1, then I can convert the random variable to a standard random variable. How? The formula will be z equals to x minus mu by sigma. If we don't have the standard normal distribution, then we need to convert into a standard normal distribution. How to convert? The random variable minus mu divided by sigma. Clear? If you see an example, you'll understand it. Okay, let's do question number 6. The length of a board produced by a machine is normally distributed. So the length of a board produced by a machine is normally distributed. So the length L follows normal distribution. Clear? Where the mean is 18.5 and the variance is 0.7. So if the variance is 0.7, so what will be the standard deviation? Root over 0.7. Tana Baba? So the mean is 18.5 and the variance is, just I'm writing in this style. You understand? Tana? Sigma is what? 0.7, root over 0.7 and variance is root over 0.7 whole square, that is 0.7. Clear? Now, find the probability that a randomly selected bolt is less than 18.85 centimeter. So now we need to find the probability that the length of the bolt is less than 18.85. So the length is less than 18.85. Clear? Clear, Baba? So if I draw a normal distribution curve, so our mean is 18. And we need to find the area less than 18.85. So 18.85 will be here, isn't it? This will be 18.85. Yes, Baba? Oh, sorry, I made a mistake. So this our mean is 18.5, sorry. 18.5. So now we need to find the area less than 18.85. So that means this much. So this is not in the form of standard normal distribution. So we need to convert them into a standard normal distribution. So let's convert into a standard normal distribution, that is z equals to x minus mu by sigma. Here the x is, the variable is 18.85. Clear, Baba? And the mu, what's the value of mu? 18.5. Divided by sigma. What's the sigma? Root over 0.7. Clear? So find the value of this much. So 18.85 minus 18.5 divided by root over 0.7. So 0.4183. So we we can calculate from the table up to 3 decimal places. So let's consider 0.418. The question is asking me to find the probability that is less than 0.418. Do you understand why it's saying less than? Because this 18.85 converted into 0.418. Clear? And this means phi of 0.418. Find the value of phi of 0.418. So this is a standard normal distribution table. Phi of 0.418. So what's the value of phi of 0.418? 0.662. So have you understood, Baba? Sure. Students from online? Chongyong?
Yes, sir.
Okay, next. Is it okay, Baba? Clear? Ready. The waiting time in minutes for patients at a clinic are normally distributed. So the waiting time follows normal distribution. So waiting time T follows normal distribution with mean 13 and variance 16. Variance is 16. So sigma will be root over 16. That is 4. Clear? Now, calculate the probability that a randomly selected patient has to wait more than 16.5 minutes. So that means the patient has to wait, the time should be more than 16.5. Clear? The time is more than 16.5. So if I draw a normal distribution curve, so this is our 13. So more than 16.5. So this is our 16.5. That means we have to find this area. But for this, we need to convert our random variable to a standard random variable. Clear? So that is z equals to x minus mu by sigma. So x will be equals to 16.5 minus mu divided by sigma. 16.5 minus 13 divided by 4. So that is 0.875. So probability of z is more than 0.875. So we need to find the probability of z is more than 0.875. So we have to use the shortcut. Z is more than 0.875. What does it mean? If we use 1 minus phi of 0.875. Clear, Yusha? Eliza? Fatima? Tazrian? So this is our 0 and this point is 0.875. Phi of 0.875. What's the value of phi of 0.875? 0.875. So this is 0.8. This is 7. And this one is 5. That means 0.8078 plus 0.0014. So what's the value? 0.8078 plus 0.0014. So that is 0.8092. Clear, Baba? 0.8092. So 0.8092. So if you subtract it from 1 minus answer, 0.1908. Is it clear, Baba? Last. Number 2. So this is our last math of today's class. Number 2. Last month, 468 patients attended the clinic. So this is the continuation of the previous. calculate an estimate of the number of patients who waited less than 9 minutes. So we need to calculate the number of patients who waited less than 9 minutes. That means it's about estimation. Clear? So first we need to find the probability the patients took less than 9 minutes. So we need to find the probability first. Clear? So if we draw a normal distribution curve, so our mean was 13. So this is our 9. So less than 9 minutes, that means this much. Clear, Baba? So first convert into Z. So Z equal to X minus mu by sigma. So X is 9 minus mu. Mu is 13 by sigma is 4. So 9 minus 13 by 4. Minus 1. Clear? So probability of Z is less than minus 1. So Z is less than minus 1 means what? Phi of minus 1. Clear? And phi minus 1 means what? 1 minus phi 1. So we need to find the value of phi of 1. That means 1.0. Phi 1.0. So this is our value. 0.8413. Clear? 0.8413. So 1 minus 0.8413. 0.1587. So now the question says last month 468 patients attended the clinic. The probability of waiting less than 9 minutes is 15.87%. How many of the patients took less than 9 minutes? So what we have to do? We need to multiply this 468 with this probability, isn't it? Yusha, do you understand? Mahira, why? Because let's say in a month, the probability of having rain is 20%. So if the month is 30 days, how many days you expect or you estimate that it will be raining? How do you calculate? In a 30 days of a month, if the chance of raining is 20%, how many days you will have rain? Mahira, how you calculate? Okay, Mahira, let's give another example. Suppose, okay, in a class of 200 students, 50% have admits. How many people have admits? 50% of 200 people. That means 50% is the percentage into the total people. Clear? Similarly, the people who waited less than 9 minutes is 15.87%. How many patients were there? 468. So just multiply 468 with this percentage. Clear, Baba? So the total number of people will be 468 multiplied by 0.1587. So 468.1587. So 74.216. So can I write 74.216? No. So what will be the answer? 74 or 75? Both are correct. With Cambridge, both are correct. But it's a book question, you get 74. So this is your answer. Cambridge accepts that. It's okay. Cambridge accepts that. Clear? But we can answer 74. It's okay. Clear, Baba? So we are done with today's class. Thank you, Baba.